Hey everybody, wanted to spend a little bit of time going over reactions today. The reaction in this video is going to be synthesis reactions. But before we get started, I wanted to go over some terminology to make sure that you understood the parts of a reaction. Here we have the reactants and the products, and I draw a line with an arrow on the arrow because that should mentally split the reaction in half. Anything to the left, typically, are the reactants. Anything to the right of the arrow are typically products. I say typically, usually, because it's the arrow that delineates them, and it's actually the way the arrow is pointed that definitely is the thing that tells the difference between reactants and products. Reactants are the part of the reaction that the blunt head of the arrow, or the blunt part of the arrow, is up against, and an arrow always points at the products in a reaction. Every once in a while you will see a reaction written backwards where the arrow goes like this. It's fine. So these are the reactants, these are the products. And the reactants are the things that you start a reaction with. This is what you end up with. The other thing I wanted to mention were diatomic elements. We talked about compounds, we talked about a lot of the elements, but there are 7 elements, and these are them right here, that exist in nature not as just one atom, but as a diatomic, or 2 atoms put together. So that means that hydrogen, when we see hydrogen in nature, we see it as H2. It's not just H. Oxygen, if you remember from biology, is not O, but rather it's O2. Fluorine is F2. And that's true with all of these guys. And these are all neutral elements, and that's how we found them in nature. And this is important because as we're in this section writing reactions, we may need to know what's diatomic and what's not. So let's start talking about our synthesis reactions. So a synthesis reaction is really just shoving 2 things together and making it. Synthesis just means to make things. And so you're going to take 2 reactants, and typically they're elements at this level of chemistry. They could be compounds, but we are going to take 2 or more of these reactants and make one product. Now, if you're unsure if it's a synthesis reaction, the thing to look at is to see if you've made something that is more complex. For example, H2O plus CO2. That's 2, and that reacts to form H2CO3. This has 3 atoms, this has 3 atoms, this has all the atoms in it, this has 6 atoms. This is definitely more complex. So while we're not starting with elements, we have 2 compounds and we make a more complex compound. So it's really 2 or more reactants making one product. Here's another example where we have sodium plus Cl2, notice it's diatomic, reacts to form NaCl, sodium chloride or table salt. That is exactly what a synthesis reaction is, where we have one product made from 2 reactants. Now, this could be a million things. You could have a million things. It's 2 or more, okay? In this case, in this specific example, we only have 2. Here, another example. Here is the AB example where we have A, which is anything, and B, which is anything, and those 2 things combine to form this idea of AB. Nothing switching, we're not burning anything, we just smush things together to make more complex stuff. Okay, so that is synthesis reaction.